Okay, the question is about an acid which is CH2XCOOH. When you react it with sodium hydroxide, there are two possible reactions. The sodium hydroxide may react with the COOH to become a salt, so minus, plus, and the sodium hydroxide can react with X to become like this, COO minus COH. Right, so sodium hydroxide can react with either the carboxylic acid or can react with the halogeno. If it reacts with the halogeno, it forms there a nucleophilic substitution. If it reacts with the carboxylic acid, it forms an acid-base reaction. And this is said in the second part of the question. Now, 4 grams of W were heated with 250 centimeter cube of sodium hydroxide. Some of the sodium hydroxide reacted with W. The remaining solution then was Fa3. So after reacting those two with sodium hydroxide, we are left with, we are getting these plus sodium hydroxide, right? Sodium hydroxide left because there was an excess of sodium hydroxide here. Now that sodium hydroxide left now is then going to react with HCl. So this is titrated with HCl. This is where things get a bit creepy in that question, in the sense that you have to calculate number of moles of sodium hydroxide many ways. Now remember, this is the amount of sodium hydroxide that you added initially. So that is an initial amount of sodium hydroxide, and that initial amount of sodium hydroxide, of course, is in excess. The acid that you are titrating, the leftover sodium hydroxide, is 0.1 molar. So this HCl is to titrate the leftover sodium hydroxide. So if I were to plug it in, I have a value of 0.1 molar NaOH, the HCl there, reacting with sodium hydroxide. Of course, for the titration, we're using 25 centimeter cube of this, and we are titrating with a tighter value of HCl, and that tighter value, I'm taking a rough value to be 24.60 centimeter cube. So let us look at the calculation part now. Now, before looking at the calculation part on the next page, we can definitely look at the calculation part right here itself. The first thing that we have to do is to calculate number of moles of HCl, and that is going to be 0.1 times 24.6 divided by 1,000, and that will give you a value of 2.46 times 10 to the minus 3. And from a balance equation that we can write between sodium hydroxide and HCl, we know that the number of moles of sodium hydroxide is going to be 2.46 times 10 to the minus 3. Now, this is the number of moles of sodium hydroxide left. So this is the leftover sodium hydroxide. And remember that leftover is found in 25 centimeter cube. So 25 centimeter cube of the leftover contains 2.46 times 10 to the minus 3. And in that question, we took there 250 centimeter cube of sodium hydroxide. So be careful about those values. This is where again is going to go ups and down. Okay, let us go back now. Let's try to see. It says to you that in that question that the halogen acid is going to react with sodium hydroxide in two ways. One, sodium hydroxide is going to react to form a salt. This is an acid-base reaction, as I've said initially. And the second one is a nucleophilic substitution. So that is nucleophilic substitution plus acid-base. Why plus acid base? We can see there that the sodium hydroxide reacted with the leftover of this one. So this is what is left over there that reacts more with sodium hydroxide to give the nucleophilic substitution. So we have this one go away. Right. So 1 mole of the acid, therefore 1 mole of acid, 1 mole of X is going to consume 2 moles of NaOH, as you can see from that equation there. I hope that this is clear. So 1 NaOH is going to react with, as the sum gives you 2 moles of NaOH, and this is consuming 1 mole of this. That is then converted into this. It's 1 mole of the X. So calculate the number of moles of HCl. So we calculated that at the back to be 2.46 2.46 times 10 to the minus 3 mole of sodium hydroxide of HCl. Then deduce the number of moles of sodium hydroxide present in 25. So that was 2.46 times 10 to the minus 3, because HCl and sodium hydroxide, they reacted 1:1. Then calculate the mole of sodium hydroxide added to 4 gram. Look at this, added to 4 gram. So added to 4 gram is this. So that is the number of mole that we added there. And that number of mole is 250 times 0.4 over 1,000. So that is 250 times 0.4 divided by 1,000. So that would be 0.1 mole, I think. 250 times 0.4 divided by 1,000. So that will be 0.1 molar. 0.1 mole. So we added there, we go back, we added there the 0.1 mole of sodium hydroxide, and remember that was in excess. So out of them, some are going to react with the acid X, but how much? So calculate the number of moles of sodium hydroxide remain after the reaction. You see, now this is number of moles of W present in 250 centimeter cube. First thing that you have to do is to calculate that the amount that is left. So you need to calculate the amount left is what. So we took, for example, we took there 2.46. So the amount of left after the reaction is 0.1. This is found in 250. And we have to subtract, yes, so let us go back. This is the amount left over. This is the leftover in 25. Leftover in 25 centimeter cube. So first we have to calculate the leftover in 250. So that's not going to be 0.1. It's going to be 2.46 times 10 to the minus 3. This is found in 25. Multiplied by 250 divided by 25. This is 4.6 times 10 to the minus 2. Left in 250 centimeter cube of solution, right? Once this is there, now we can calculate the number of moles of sodium hydroxide that reacted. Sodium hydroxide reacted is 0.1 that we had initially minus leftover 2.46 times 10 to the minus 2. And if we minus 2.46 times 10 to the minus 2, we're getting there 0.0754, if I'm not mistaken about my calculation there. Right, number of moles of sodium hydroxide that reacted with W. Hence, calculate the mole of W that reacted with sodium hydroxide. Now, this is the amount reacted. So let us go back. This is the amount reacted. The amount of sodium hydroxide reacted is so much. So amount of sodium hydroxide reacted is so much. Right? Calculate the number of moles of W now. Number of moles of W is 1:2. Number of moles of W equal 0.0754 multiplied by 1/2, because 2 moles of sodium hydroxide reacted with 1 mole of W, and that gives us, if I'm not mistaken again there in my calculation, 0.3037 mole. Right, hence use your answer to free and the mass to calculate, to make Fe free, to calculate the MR. Now you can calculate the MR by saying that number of moles equals to mass divided by AR/MR. So MR equals to mass, which is, so we took there 4 grams of W, 4 over 0.0377, that gives us 4 divided by 0.377, I don't know. So that is around 11, I think, right? Okay, that is, I think, around 11, no, isn't it? 4, no, I don't know, 0.0377, isn't it? No, it's around 110, 106. Right, so once we have it to be 106 now, we can calculate now the value of W. So CH2XCOOH equals to 106. So if we minus every part there, 12 plus 2 plus X plus 12 plus 16 times to 32 plus 1 equals 206. So x is evaluated to be 106 minus the remaining there, minus the remaining minus 12 minus 1. So I think I've obtained 47 there. Then you can use 47 there. You can go and see which one is closer to it from the periodic table, right? So the tricky part of that question was this dilution and this reaction. Let me explain it back again at last here. So first we had 4 moles of W, right? You should remember this well. We had 4 moles of W, 4 grams of W. That 4 grams of W is an acid, CH2X-COOH. We are adding an excess of sodium hydroxide, that's the excess, and we add them in 250 centimeter cube. So there is a reaction where sodium hydroxide reacts a first time, forming this one, and a second time forming this one. So this is a tricky part. So 2 moles of sodium hydroxide has been used there. The first sodium hydroxide and a second sodium hydroxide for 1 mole of this acid. And this is now in 250. Then it left over sodium hydroxide there, and that leftover sodium hydroxide you are now titrating with HCl, and the concentration of HCl there provided was 0.1 molar. So that was 0.1 molar. And then we perform the calculation to obtain number of moles here. Once we have number of moles, we get number of moles of sodium hydroxide. But remember, this is in 25. Then we get number of moles of sodium hydroxide now in 250, 10 times more. Once this is over, now we get the number of moles of the acid, and that is a factor of half. And once we have it, we get the mass, we get the mR. From the mR, we get the value of x. Voilà. So I hope it is easy and you can complete it.